Hello everyone. Today we are studying the next part of Unit 1, that is digital and analog transmission. A computer network is designed to send the information from one point to the other. It is necessary to convert this information either digital signal or analog signal for transmission depending on the transmission medium and application. The concept of digital signaling, in which input signal, that is analog signal or digital signal, is encoded into a digital signal. There are four encoding types. First is digital data, digital signal. Second is analog data, digital signal. Third is digital data, analog signal. And fourth is analog data, analog signal. So first conversion is digital to digital conversion. In this type of encoding, digital data, which is normally binary in nature, is converted into the sequence of discrete discontinuous voltage pulses. That is your digital signal. The figure shows the conversion of digital data to digital signal. Some binary data in 0 and 1 format is sent to the encoder. Encoder does the transmission from digital data to digital signal. The digital data at the input of encoder may not be suitable for transmission over the longer distance. Hence, it is converted into digital signal, which is more suitable for long distance communication. The digital signals at the output of the encoder are known as the line code. The basic concept of line code is the process of converting binary data, a sequence of bits, to the digital signal. Some characteristics of line coding is signal level and data level. Second is pulse rate and bit rate. Third is a DC component, and fourth is self-synchronization. So digital signal level is the number of values allowed in the particular signal, is defined as the number of signal levels. Data level, the number of value represented data, called as a number of data level. Pulse rate. Pulse rate is defined as the number of pulses per second, and the pulse is defined as the minimum amount of time required to transmit a symbol. Bit rate. Bit rate is defined as the number of bits per second. In one pulse correspond to one bit, then the pulse rate is equal to the bit rate. But if the pulse carries more than one bit, then the pulse rate is lower than the bit rate. The relation between bit rate and pulse rate is as follows. Bit rate is equal to pulse rate into log to the base 2L. Next conversion is analog to digital conversion. The process of converting analog data to the digital signal is known as a digitization. The process is essential in all digital communication systems such as pulse code modulation, PCM, or delta modulation, DM. In order to carry out this transformation, one has to follow the sequence of operations such as sampling, quantization, and encoding. So basic concept is, there is ADC, the input signal is passing through the ADC and we will get the digital signal. So pulse code modulation, PCM, is a type of pulse modulation like PAM, PWM, or PPM. But there is important difference between PAM, PWM, and PPM are analog pulse modulation system, whereas PCM is the digital pulse modulation system. That means PCM output is coded digital form. It is in the form of digital pulses, constant amplitude, width, and the position. Next conversion is digital to analog conversion. Digital in the process of digital to analog conversion, the digital data at the input is converted into the analog signals. Thus, these analog signals are transmitted over the transmission medium. The most familiar application of digital to analog conversion is for transmitting digital data through the public telephone network. The digital to analog conversion is done by the modern modems to convert the digital data from the computer into the analog signals that are sent on the telephone lines for the internet. The aspect of digital and digital to analog convergence are data elements versus signal element, and second is data rate versus signal rate. Data element versus signal element, we may define data element as the smallest piece of information that can be exchanged, and as we know, it is a bit. The signal element is classifiedly defined as smallest unit of the signal that is constant. This definition is true in the digital context, but the signal will analog here. Hence, the nature of the signal element is slightly different than the digital transmission. Data rate versus signal rate. We have defined the data rate or bit rate and the signal rate, that is baud rate, earlier. The relation between them is signal rate is equal to n into 1 upon f baud, where n is data rate and r is number of data elements in one signal element. And last type of conversion is analog to analog conversion. In some application, we have to transform analog data such as voice, video, etc. into the analog signal. This process is known as the modulation. The analog data at the input is called as a modulating signal. It modulates a high frequency sinusoidal signal called as a carrier to produce another analog signal called modulated signal. There are three types of analog to analog conversion. First is amplitude modulation, second is frequency modulation, third is phase modulation. So amplitude modulation with full carrier is the process of changing amplitude of the high frequency sinusoidal carrier signal in the proportion with the instance value of the modulating signal. The frequency of sine wave carrier is much higher than the modulating signal. In amplitude modulation, instance amplitude of sine wave is highly frequency carrier changed in the proportion of instant amplitude of modulated signal. This is the principle of amplitude modulation. The time domain displays of amplitude modulation signal is transmitted by the transmitter. The information in amplitude modulation signal is contained the amplitude variation of the carrier of the envelope. The frequency and phase of the carrier remain constant in amplitude modulation. Amplitude modulation is used in the applications such as radio transmission, TV transmission. Second is frequency modulation. In sine wave, frequency modulation is the signal is equal to E cos 2 pi f t is the pure sine signal. The carrier signal is also sine wave, much higher with much higher frequency. The frequency modulation is a system of modulation in which instance frequency of the carrier is varied into proportion with the amplitude of the modulating signal. The amplitude of carrier signal remains the constant. Thus, the information is converted via frequency change. Frequency modulation was the first practically tried into 1936 as the alternative to amplitude modulation. As the transmission is more resistant to the noise than amplitude modulation, the time domain displays of frequency modulation wave is shown. The amount by which the carrier frequency deviates from the unmodulated value is called deviation. The deviation delta is made proportional to the instance value of modulating voltage. The last type of analog to analog conversion is phase modulation. Phase modulation is very similar to the frequency modulation. The only difference is that the phase is carrier various instead of various frequency. The amplitude of the carrier remains constant. The modulating signal goes positive. The amount of phase increases with the amplitude of the modulating signal. The effect of this is that the carrier signal is stretched or its frequency is reduced. When the modulating signal goes negative, the phase shift becomes leading. This causes the carrier waves to be effectively compressed. The effect of this is an carrier frequency increase. Thus, the phase modulation is always associated with frequency modulation and vice versa. The phase modulation wave is same as the frequency modulation wave produced by the dx by t upon dt, that is the derivative of xt with respect to the time. Thank you.